So now we will see one by one what is the idea behind each unit operation. First of all, we will see absorption. In absorption, suppose you have a gas. Nowadays you know that gas contains very harmful NOx and SOx gases in the air. So if we want to remove the sulfur dioxide from the air, so we know from the thermodynamic data that water, this sulfide gas, is more soluble in water or any alkali. So what we will do, we will utilize water to absorb this SO2 from this mixture of air so that we will get the pure air. So if we want to do this operation, first of all the principle is solubility. Solubility of SO2 in water. So now where we will do this, we will require an equipment. So generally we prefer to use a packed column. In packed column, what we will do, we will flow the water from the top to the bottom and the gas mixture A plus B from the bottom. So what will happen, as water will move in the downward direction, it will take the sulfide, that is SO2, from the air gas mixture, and you will get a pure air at the top, and at the bottom you will get the contaminated water, that is with the SO2. So this is the operation of absorption, which is based on solubility. Next unit operation we have, that is distillation. So what we do in distillation, suppose you have the mixture of propane, butane, or you have the mixture of oxygen, nitrogen. So first of all you have to convert it into the liquid form, then you have to separate it. So what we do here, we first of all heat the mixture, so that, because we know oxygen and nitrogen both have different melting and boiling point, so we utilize the difference in melting point in order to separate the mixture of oxygen and nitrogen. So in top product you will get oxygen, suppose 1%, and nitrogen 99%, and here you suppose your nitrogen is 1% and oxygen is 99%. Okay, so difference, based on difference in their boiling point, you will get the high volatile at the top and less volatile at the bottom. So this is the distillation, where we utilize the energy to separate the two components. Next we have the extraction, or we call liquid extraction. So what we do in liquid extraction, suppose you have water which contains some arsenic, nicotine, or some heavy metal, and you want to separate it. So what we will do, we will utilize the kerosene as a solvent here to remove the nicotine from the water. So we will mix them thoroughly and we will remove the nicotine. So what will happen here, the creation of two phases, what I told, two phases are must. So nicotine will go in water and some nicotine will go in the kerosene. What we will found, because solubility of nicotine in kerosene is more, so more nicotine will be in the phase 2 and less nicotine will be in the phase 1. So we will get a water which contain less amount of nicotine. So here difference in solubility of nicotine in water and kerosene has been utilized to separate nicotine from the water. Similar principle of liquid extraction is utilized in the principle, or you can say unit operation, of leaching. In leaching, what we will do, we have the solid which contains some component, suppose C, that you want to separate from this. So what we will do, we will use a solvent that will extract the C from this material. Like you take example of tea in your home, which you are making daily. So what we do, this tea contain, that is the solid tea, some, you can see you have this granules of tea. So this contains some tea that has a component C. Suppose C is the component, some material of tea that you want to extract. So what you will do, you will send the milk here. So what milk will do, milk will absorb the tea from this all solid particle and you will get the solution of tea, and some tea will be still in this. So what we have done, we have done leaching. So this is same like liquid extraction. Another unit operation is what? Adsorption. What we do in adsorption, generally we see, suppose air contains the moisture. So we know that silica gel, which has the more surface property to extract this moisture. So what we will do here, we will utilize the solubility of moisture on the surface of silica gel, or you can say adsorption. This phenomena is called adsorption because it is surface phenomena. So here, based on the affinity of the moisture towards silica gel, we use the mass transfer operation of adsorption. Like that, we have one more unit operation, that is drying. This is very different from the other unit operation because it involves both heat transfer and mass transfer. What happens, suppose you have some sand, it contain a large amount of moisture, you want to remove the moisture. So how we will remove? We will remove with the help of drying. So what happens by drying? We will send the hot air. So hot air will take the moisture and sand become less of moisture and air become high of moisture. So this is the principle. What is happening here? We are changing the temperature as well as we are changing the concentration of water in both the phases. So it involves both mass transfer and heat transfer. So what are the set of questions that may be asked with you as a design engineer or a chemical engineer in the GATE exam? So they may ask, what is the amount of solvent that is required for the process of leaching or the process of extraction or the process of absorption? How many stages, how many equilibrium stages are required to perform a particular set of operation? How much diameter of column is required? How much length of the column is required, how much separation you want to do, and they may ask the question based on hydrodynamic study. So these are the set of questions that may be asked with you. So generally we have two types of approach in mass transfer. One is called rate wise approach, other is called equilibrium approach. In rate wise approach, we define the mass transfer flux, that is kilomole of any component that is transferring per meter square per second from any at any point. Generally rate wise approach is utilized in absorption. Now other is equilibrium approach. Equilibrium means here we consider the stages for mass transfer to happen. Generally in distillation we use equilibrium approach.